Good evening, my YouTube viewers. Crystal here. What I wanted to do tonight is I wanted to go over with you a program that I was working on all day long. Basically, I've just got a little Chromebook and it's not very powerful. And if I had a more powerful computer, then I would be able to get better scores. But I tried several models and my computer kept crashing and it was really slow. And so I just decided to stick with the model that I got. But if I had a better quality computer with more memory, I probably would have gotten a better rating. But I'll go ahead and go over this with you. This was an Analytics Vidhya hackathon, and it was hackathon number 3. It was a guided, says Hack Live 3 guided hackathon NLP, and it's on the Analytics Vidhya website. The files were so large that I was not able to save them on a GitHub repository. I had to save them on my Google Drive. They were so large because GitHub places limits on how large the files can be that you put on the repository. But I did actually put the program on the repository under miscellaneous predictions, so you can always call the program up and follow along with me. So the first thing we're going to do is we're going to discuss the problem statement. It says researchers have access to large online archives of scientific articles. As a consequence, finding relevant articles has become more and more difficult. Tagging or topic modeling provides a way to give clear token of identification to research articles, which facilitates recommendation and research process. Earlier on the Independence Day, we conducted a hackathon to predict the topics for each article included in the test set. Continuing with the same problem, in this live hackathon, we will take one more step ahead and predict the tags associated with the articles. Given the abstracts for a set of research articles, predict the tags for each article included in the test set. Note that a research article can possibly have multiple tags. The research article abstracts are sourced from the following 4 topics: 1, computer science; 2, mathematics; 3, physics; 4, statistics. And then they give you a list of tags, which is 25 tags in total, but I'm not going to read those. You can read them yourself. So the first thing we do is we import our libraries. And then the second thing we do is we load and read the files. And as I said, I was not able to save these files on GitHub, so I had to save them on my Google Drive. But I do have my file on GitHub, so you can always go to my file under Tracy Renee 61 and get the program. It's under MISC Predictions, and it's AV Tags on Books, IPYNB. So we look at the train file, and you see the train file. It has an ID, an abstract, 4 books, and then 25 tags. You look at the test file. The test file does not have the 25 tags. And then we have the tags. These are our 25 tags. And we have a sample submission. So the sample submission is an ID and the 25 tags. So what we do is we check for any null values, and in this instance, there were not any null values that needed to be imputed. And so the next thing we do is we want to graphically represent the data. So you've got 42% of the books were computer science, 20% of the books were mathematics, 27% of the books were physics, and 7% of the books were statistics. Because you have to remember that a book could have more than one book could have more than one subject matter to it. So what I wanted to do is originally I decided I was going to replace the Boolean values with words. So I went through, and instead of 0 and 1, you just had a space and computer science. Because what I wanted to do was I wanted to add the subjects to the abstract column, but whenever I ran the program, I was not able to do that. It didn't work. So when I ran the program and it didn't work, I had to delete part of the program. But I went ahead and left those files in there. But it doesn't really detract from the program because I didn't use those 4 columns anyway. So now what we do is we import our HTML parser. Now that would come in handy if you were doing a web scraping. Then what we do is we create a new column called process text. And that column is actually the abstract column in the train and the test file, because the process text is where we're going to be processing all the information, and we will be keeping the abstract file as it is. So, again, this was what I had originally done. Was over here, I had originally added the different columns to process text, but whenever I ran the program, it didn't work, and so I had actually deleted those those columns, but left the main column in there. So strictly speaking, nothing really needed to be done to it, but I left it in there. I didn't actually delete it. And now what we do is we import the files that we need for the natural language processing. So we import the Porter stemmer and we import the stop words. And so we put a function in there to stem the abstract for the train file and the test file. And then what we did was we further processed the data. So we made all the words lowercase. We removed special characters, numbers, punctuation, and removed any words less than 3 characters. And now you see this is just a little picture that tells you all of the words that are in the abstract. And you can tell that the words have been stemmed. What we do is we define our target. Your target is your 25 columns of your tags, and your Y data is those 25 columns of the tags train target. And so now we do is we plot this on a graph, so you can see that most of the books were in actually machine learning, which is what I'm studying now, machine learning, and why I'm making this video for you. And now what we do is we define our X, Y, and X test. So Y is train target, X is train process text, and X test is text process text. And then what we do is we split split our train setup into X train, X val, Y train, Y val. And you'll notice we shuffled the train set, but we didn't stratify it. When I tried to stratify it, it didn't work. So you shuffle it, but you don't stratify it. Now what we've done is we've used our TF-IDF vectorizer, and when we use our TF-IDF vectorizer, that's part of the sklearn, and what it does is it takes all the words and it assigns all the words to a number. And then what we do is we check the shape of train, TF-IDF, val, TF-IDF, and test TD-IDF. And now what we do is we define our model, and the only model that I could get to work with any reliability was linear SVC. And I think a lot of that is to do with the fact that my computer is not very powerful. If I had a more powerful computer, then I possibly could have gotten a better rating. But when I was doing this problem, my computer crashed several times, and somebody posted and said he ranked number 6 by using logistic regression, but I couldn't get logistic regression and MLPC and a lot of the others to work because it was just taking such a long time to go through it. And if I had the time to sit there and let it churn through for a day or so, then it may have worked, but I didn't have that amount of time to do it. So then we fit our model, and when we fit our model, we had a 64.36%. And then now what we did was we predicted on our validation set, and we got a 35.47%. And as I said, if I had a more powerful computer with more memory, I probably would have gotten a higher score. So now we do our precision, recall, F1 score, and support, and it gives you that information on all of the 25 tags. And so now what we do is we predict on our test set. And then after we predict on our test set, we have to create our data frame. And then so we have test ID as your ID, and then we have the 25 tags is one column in prediction. So I had to do all that. And then what we do is we submit this to the Analytics VidHighest Solution Checker, and I got a 67%, and the highest rating was 80%. But if my computer had been more powerful, had more memory, then I may have been able to get a higher rating. But my computer, it just crashed. It just couldn't cope with the complexity of this problem. And that's one of the problems with these competition questions. The files are really large, and my computer just can't cope with it. But I do intend on getting a new computer next year after my birthday. So that concludes this presentation on solution to this